Hey everyone, and welcome for the third day of 30 Days of CNCF project. And today we are going to talk about an amazing project called KEDA. And KEDA basically allows you to autoscale your event-driven system based on any metrics you like. It's going to be awesome. We are going to talk about what is KEDA, how it works, and show you a demo so you can use KEDA. Let's go. What is KEDA? So KEDA is a Kubernetes-based event-driven autoscaler. What it allows you to do is to scale your Kubernetes application deployments and number of pods based on event-driven system metrics. For example, let's say that you want to scale anytime your lag in the Kafka stream getting above X seconds, or you want to scale based on the number of events you got in a queue. All of that can be done using KEDA, and it's really hard to get at using the basic HPA. So KEDA basically allows you to scale your application based on a wide variety of integrations, events, and systems. We are going to see them later in this video. What is the value of KEDA? So in order to understand that, we need to take one step back and talk about the challenges and limitations of Kubernetes native HPA or horizontal pod autoscalers. So let's say that we have a use case, and in the use case we have Kafka consumers consuming actually events from Kafka stream. And once in a while, we get a lot of events into the stream and our consumer need to consume them, but they need to autoscale based on the number of events or the lag we got in the stream. Native HPA is a little bit limited, so it can work with CPU, memory metrics, some custom metrics using Prometheus. Those are hard to define. But with KEDA, we can create a scaler that is native to Kafka. And based on Kafka metrics and metrics that defined in the Kafka stream and in the Kafka cluster, we can use those to get much better autoscaling that fits our use case and our application. How we would do that? We will deploy KEDA, we will define a Kafka autoscaler, we will connect it to our clusters, and that's it. We got autoscaler based on Kafka. And I have to say that one important thing is that Kafka is only one example. If we are going into KEDA website, there are a lot of scalers. Let's see a few examples. So in here, for example, when we are taking a look, we have the scaler on the website. We can see ActiveMQ, Apache Kafka, whatever on the left side, Datadog, CouchDB, databases, cron jobs, cloud providers, basically whatever we like, Locky, Redis, databases, whatever we like in order to autoscale our own application. So basically KEDA, although it's event-driven, basically, it allows you to extend the autoscaler of Kubernetes to be whatever you like it to be. And this is what is unique about KEDA. It solves dozens of use cases. How KEDA works? So KEDA works pretty similar to HPA. It's just that KEDA is not a Kubernetes native resource. So in order to define our policy, we will define CRDs and CRs. In this example, we will also deploy our own application. And when we define a policy to scale based on the lag in a Kafka stream, KEDA will always follow and monitors the Kafka stream. Once it hits the threshold, then KEDA will trigger autoscaler on our deployment. And that's it. It's as simple as it can be. But let's go one step deeper and understand how KEDA works behind the scenes. To understand the next layer of KEDA, we need to define two terms. One called scaler. Scaler is the integration with any tool that you would like that allows KEDA to follow this resource and scale based on it. You can define it as some kind of integration, and previously we saw all the scalers that KEDA got, which is a lot. The second term, called scaled object. Scaled object is a CR that defines the autoscaling policy that we want to scale on. So what we will define is what is the target resource, which resource to scale when we want to scale, let's say a deployment, And what are the triggers? The triggers are based on the scale that we have previously. So we want to define basically what to scale, when to scale. Now let's take a look how it looks behind the scenes. Now let's go back to our application from previously and break KEDA into smaller pieces. So on the bottom left side, what we got is the KEDA operator responsible to operating all of KEDA amazing system. At the bottom, we got our CR scaled object, which defines exactly what do we want to scale and what are the threshold for scaling. Now we have two components, the main components of the KEDA operating flow. One is the KEDA metric server. The KEDA metric server actually uses the scaler in order to connect into the target system and integration that we have, for example, in here it's Kafka, and fetch the relevant metrics from the Kafka topics or cluster. And then KEDA uses the HPA native mechanism and utilize it to do the autoscaling. So it will create an HPA for the consumer and it will follow the metric server deployed by KEDA. So KEDA actually takes information from the remote object, like from the Kafka topic in this example, translate it into metrics that the native HPA can work with, and then deploy a HPA that will do the autoscaling. So there's no need to rewrite the autoscaling mechanism of the HPA in Kubernetes. And this is amazing because we define a scale object, then KEDA creates everything it needs, HPA, create the metrics, do the connectivity, and from that on, we got autoscaling based on our remote or scalar target system. Now that we understand how a simple example works, let's take a look about the full architecture. So we can see our scaled object, a CR that we define in the Kubernetes API, and KEDA got a few components that helps us to operate the thing. One is the metrics adapter, works with what we call the metrics API that the HPA connects to and then define and fetch the metrics from it. It also defines the HPA itself, the controller that controls everything, the scalars that actually connects to the external trigger source, which in our example was Kafka, but it can be any one of the scalars that we saw. And that's it. That's the full way of how KEDA works and how you can autoscale your own application based on any scalar KEDA got to offer. Before we are moving next, I want to show you a little bit how big and how many varieties of use cases KEDA can support. So one of the things that we already saw is to scale based on event streaming. This is really useful. It can be integrated with Kafka, with RabbitMQ, SQS, and other queuing and streaming services. Another thing is scale based on metrics. There are the Prometheus one, which is kind of native, but you can scale based on metrics from external systems like Datadog and New Relic, which is kind of useful and new. You can also scale based on values in the database. You can connect your KEDA to Postgres. It will run a query, and based on it, it will scale your number of workers, which is really cool. Also scaling based on cron. If you have some night shifts or night job that you want to scale a specific time of the day, that can be useful too. Scale based on number of queue jobs in runners, in pipelines. For example, if you have GitHub Actions, or Azure Pipelines or GitLab runners, you know that you need to manage your runners. And that allows you to basically scale a runner for every job that you have in your queues. Really, really useful. Also scale based on object storage. If you have some, new item on your S3, you can spin up a new worker for that. So KEDA got a lot of varieties of use cases. You can go into the scalar page and find out more. I have to say that I'm very impressed with how many use cases and real life examples that can support. Before we are starting the demo, I wanted to talk a little bit about what is the value of KEDA and what are the alternatives out there. So 5 years ago, when there was no KEDA and people would need to scale because those use cases I just talked about, nothing from them is new in the last 1 or 2 years. So the main solution for most of the teams was actually to develop their own autoscaler. That is nice because you can fit it really, really well to your own use case. But the problem is that you need to maintain the code and make sure it works, especially when Kubernetes change version or you have new requirements. So KEDA actually streamlined all of the autoscalers into a single place. This is really, really useful. So the value in it is that you can enjoy the autoscaling for your own use case without creating your own custom code and your own KEDA whatever custom autoscaler. Obviously, there are other alternatives out there, but most of them and the most good them I saw are just custom code tailor-made for their use case. And now I want you to see how KEDA actually looks in live action. So for this demo, what we are going to do is to deploy application as we saw before. We are going to have a Kafka cluster and a Kafka topic, and we are going to deploy them using Streamzy and other CNCF projects, which is going to be later in this project. And we are going to deploy two deployments. One, a producer that will produce events and put them on the Kafka topics. And the other one is a consumer, which will autoscale when the lag in the topic will be too much. So for that, we are going to use KEDA and Streamzy. I'm going basically to deploy KEDA as you see it in here. As for every one of our demos, you can find them on the GitHub called How to DevOps Tools. I will add the link into the description. And what I'm going to do is that basically I'm going to deploy KEDA and I'm going to deploy Streamzy. So all the Helm chart actually updated on my environment. So this is why I didn't did the add repo and install. And what we're going to do next is that we're going to create a Kafka cluster. How we do that? Streamzy allows us to create Kafka clusters using CRs, and Streamzy is basically a Kafka operator. So we will define our Streamzy or Kafka cluster in here, and we will just copy, paste, and deploy it. Created successfully. And what we want to do next is basically to deploy a topic. In the topic, we will write and will produce and consume our events. And now we got our Kafka topic. How can we check that? We can do kubectl get Kafka topics, and you will see the Kafka topic in here. And we also check our Kafka. I think it's called just Kafkas. And we can see that our Kafka cluster and Kafka topic actually spin up. It will take them some time to be created, but at the same time, we're going to create our application. So what we got in here is a consumer. The consumer is a dummy one. What it's going to do is basically nothing. So we are going to add and produce events into the topic, but on the other side, we are going to have a deployment that actually does nothing. And that will make the lag in the Kafka topic to be just increase over time. And KEDA will always try to autoscale our consumer dummy based on that. So let's deploy our consumer. And what we're going to deploy next is our scaled object for this consumer. So let's have a look at it before we actually define it. And what we can see in here is that this is the scale object YAML. We can see, first of all, what is the target reference. We can see it's a deployment and the consumer dummy is our deployment. We can see that we have the polling interval, the min and max like we got in HPA. And what is more interesting is the trigger. The trigger is basically our scaler. And we can see in here that we are using the Kafka scaler. It's going to be connected to that consumer group. These servers are the Kafka cluster, and this is the name of the topic. And that's the threshold that we want to define. So we are going to take that and we are going to deploy it. And what KEDA is going to do behind the scenes is that it's going to, first of all, being connected to our Kafka cluster, spin up the API to be matched to the HPA, and also create the HPA. It can take some time. It can take 1 or 2 minutes for everything to be created. Let's create our producer at the same time. So what we have in here is a producer. It's a simple, very simple Kafka producer. What you can see in here is just basic application. We are using Kafka image because it's got all the binaries packed in. And what we can see in here is basically a script that adds event to the Kafka topics, continuously adding more and more events, making the topic to grow, but because the consumer does not consume them, it's going to actually make the lag just increased. Okay, so let's deploy that. Okay, cool. So now we got a producer. Let's make sure that our Kafkas are ready. So now we can see that everything is ready and up and running. We can also use that to check the Kafka topics that we have. Oh. And now we can see that everything is up and running. We can see our scaled object. And now our scaled object is ready. We can see that. Oh, we can see that it's ready, active, and no fallback, and not paused, running for almost 2 minutes. What we are going to do next is that I want to show you the HPA that just got created. And we can see that the KEDA HPA scale producer, we can see that it's got like different targets. So if I'm going to describe this HPA, you can see that it's not a regular HPA. It's defined only for that. It's using this metrics, 3 out of 3. The min and max is actually what we defined in the scale object. And you can see failed get external metric. It was a long time ago, but it's going to check the scale metrics on the API we defined. So this is the way to troubleshoot and understand that everything works in the Kafka topic. And now what we need to do is that we need basically to wait and to see that our consumer actually get increased because of the lag that we got. We have what I've added in here are a few commands that can use in order to connect to your Kafka and see, for example, how much events we got, what is the lag, reset the lag, and also to query KEDA to find out some information. So what is really cool is that because KEDA actually exporting the API and the metrics through its custom API, we can take this command, put it in here, and see exactly what happens. So in here, for example, we can see that we get the external value list. We can get that the value of this metrics is 1. And let's wait a little bit and see what happens when it scales. Obviously, based on your use case, it will scale as fast as your application will scale. So let's wait a little bit and see how it goes. What I did is that it took it a little bit longer. So I scaled the producer, making it to produce much more events. And now we can see that we have much more consumer added by KEDA. So let me show you an example of how it looks. So if we are going to query the metrics like we did before, we can see that the value is now 7, which means that we got autoscaled twice. We can take a look about the HPA, and we can see now it's aimed to 3 replicas. I wonder if maybe a describing here will show us the autoscaling. Yeah. So we can see, let me make it a little bit easier to see. We can see near the new size and the autoscaling happened because of the external metrics we just got, which is kind of cool. And next we are going to get the scaled object. And in new, what we can see is that it's ready, active, and let's describe the scale object. Cool. And based on that, we can see everything around our scale object. Now with the spec, whatever we have in here, and let me find out. Status, by the way, is happy, not healthy, which is kind of nice compared to other things. And we don't have the events in here, just created it. Cool, so amazing. And now we will manage to actually create our own autoscaler based on KEDA. And as you can see, a minute ago, it's also spin up a new consumer. And that's how easy it is to run Kafka autoscaling using KEDA. That was the third day of 30 days of CNCF project. I hope you enjoy and now you know more about KEDA. And we got one thing to do to add a sticker of KEDA into the board. So let's do that. And now we got 3 days. Thank you very much for watching. See you tomorrow.